The birth of our solar system and our place in the galaxy. Chapter 1. The Primordial Cloud. In the beginning, about 4.6 billion years ago, our solar system did not exist. Instead, there was a vast molecular cloud of hydrogen, helium, and trace amounts of heavier elements floating quietly in a corner of the Milky Way. Gravity, ever the patient sculptor, began to pull parts of this cloud together. As turbulence rippled through the gas, denser clumps formed, and one of them became the seed of our sun. This event was not isolated. Countless stars are born in such stellar nurseries. Our solar system's story is, therefore, part of a much larger cosmic cycle. Matter from older stars exploding as supernovae enriched this cloud, ensuring that when our sun and planets formed, they carried within them the building blocks of life. Chapter 2. The birth of the sun. As the cloud collapsed, matter funneled toward the center. Pressure and temperature rose until nuclear fusion ignited, and our sun was born. This young star blazed with intense energy, sending streams of charged particles outward. Its radiation began shaping the surrounding disk of dust and gas, pushing away lighter elements while allowing heavier ones to settle closer. In its infancy, the sun was less stable, often flaring violently. Yet this chaos was necessary. The solar wind cleared the path, ensuring that planets forming nearby wouldn't be swallowed in excess gas. The sun, now a middle-aged star, still carries the memory of its turbulent youth. Chapter 3. The protoplanetary disk surrounding the young sun was a rotating disk of dust and gas, the protoplanetary disk. Within it, microscopic grains collided and stuck together, forming larger clumps. Over millions of years, these clumps became planetesimals, the building blocks of planets. The inner region, closer to the sun, was too hot for volatile compounds like water and methane to remain solid, so rocky planets, Mercury, Venus, Earth, and Mars, emerged there. Farther out, where it was cooler, icy materials could condense, allowing giant planets like Jupiter and Saturn to grow massive. This simple difference in temperature distribution set the stage for the solar system's architecture. Chapter 4. The Giants Awaken. Jupiter, the largest planet, grew quickly. Its immense gravity influenced the orbits of countless planetesimals, shaping the asteroid belt and preventing another planet from forming there. Saturn, with its elegance, followed, and beyond them, Uranus and Neptune emerged in the colder reaches. These giants were not only massive, but also migratory. Early in the system's history, their orbits shifted, scattering debris everywhere. Some of this material bombarded the inner planets, delivering water and organic molecules, gifts that would later help life flourish on Earth. Chapter 5. The Making of Earth. Earth began as a molten sphere, shaped by endless collisions with planetesimals. One of the most dramatic impacts came from a Mars-sized body, Theia, which struck young Earth with immense force. The debris from this cataclysm eventually coalesced into our moon. Over time, Earth cooled, forming a crust, oceans, and atmosphere. Volcanic outgassing and asteroid impacts enriched the planet with carbon, nitrogen, and water. These ingredients brewed the chemical soup from which life would one day arise. Unlike its neighbors, Earth found itself in the habitable zone, close enough to receive warmth, yet far enough to avoid runaway greenhouse conditions like Venus. Chapter 6. The Moon's Silent Watch. The Moon became more than just a companion. Its gravity stabilized Earth's tilt, ensuring long-term climate stability. Without it, our planet's axis might have wobbled chaotically, leading to extreme seasons that could hinder life's evolution. The Moon also influenced tides, which in turn nurtured coastal ecosystems where early life may have thrived. From ancient times, humans looked at the Moon as a guide and storyteller in the night sky. Yet its origins remain written in the scars of its cratered surface, a silent witness to the solar system's violent youth. Chapter 7. The Dance of the Inner Worlds. Mercury, Venus, Earth, and Mars each tell a different story. Mercury, scorched and airless, reveals the sun's harsh power. Venus, shrouded in toxic clouds, shows the dangers of a runaway greenhouse effect. Mars, smaller and colder, once had rivers and lakes, hinting at a wetter past. Earth alone became a cradle of life. Studying these neighbors not only helps us understand planetary diversity, but also reminds us of Earth's fragility. They are like siblings who shared the same birth, but grew into drastically different destinies. Chapter 8. The Outer Realms. Beyond the asteroid belt, the giants reign. Jupiter, with its swirling storms like the Great Red Spot, acts as both protector and threat, deflecting some comets while occasionally sending others inward. Saturn's rings, dazzling yet delicate, are remnants of shattered moons or icy debris. Uranus, tilted on its side, spins oddly, while Neptune's winds roar faster than sound. And far beyond lies the Kuiper Belt, home to Pluto and countless icy worlds. These distant realms remind us that our solar system is not just about the familiar planets, but also about a vast frontier of mystery. Chapter 9. Our Solar System in the Milky Way. Our Sun orbits the center of the Milky Way once every 225 to 250 million years. It resides in a spiral arm called the Orion Arm, between the larger Sagittarius and Perseus arms. From here, the night sky reveals billions of stars, but they are only a fraction of our galaxy's 100 to 400 billion. Our solar system is constantly moving, drifting through interstellar space, influenced by the galaxy's tides and the gravity of passing stars. This perspective reminds us, our home is not just Earth, not just the solar system, but an entire galaxy alive with motion. Chapter 10. Our Cosmic Address. When we think of our place in the universe, we can map it like an address. Earth, solar system, Orion Arm, Milky Way galaxy, local group of galaxies, Virgo supercluster, and beyond into the observable universe. Humanity is still young, but our curiosity drives us to explore this cosmic address. From sending probes beyond the solar system to building telescopes that peer into the first moments after the Big Bang, we are slowly connecting the dots of our origin. The story of our solar system is, ultimately, the story of us. Matter that once drifted in a cloud, now looking back at the stars with wonder.